In this video, we're going to go over the KutaSoftware Infinite PreAlgebra free worksheet scientific notation. I'll leave a link in the description below so you know how to access this free worksheet. Our directions for numbers 1 through 6 are to write each number in scientific notation. Now remember, scientific notation is just a way to concisely write a number according to different powers of 10. So let's dive into number 1. Now, let's quickly go over the form of scientific notation. Scientific notation is the form of we have a ones place, a decimal point, followed by the remaining decimal. We multiply that number by 10 to some power. That's the form of scientific notation. We have a ones place, some numbers to the right of our decimal point, and then we also have to figure out the power. So diving into number 1, eliminating those leading zeros, we would want our ones place to be 7 and the remaining decimal to be the 8/6. So putting our decimal here, we'll have 7.86 times 10 to the, now we just have to figure out what that exponent's going to be. Well, think about it. If we have our decimal place here, how many times did we have to move it to get back to the original? 1, 2, 3, 4, 5, 6, 7. You can see that we had to move it 7 times. So because we moved it a total of 7 times, our exponent is going to be, well, either a -7 or a +7. And think about it. 7.86 is a number larger than 0.00000786. So we want that to be to the negative exponent. So it's 7.86 times 10 to the -7th. That's our solution in number 1. And again, I decided that that was a negative exponent because in order to get this original number, we would have to move the decimal place to the left, making 7.86 smaller. But 7.86 times 10 to the -7th is equal to this decimal in number 1. Let's move on to number 2, continuing these concepts. In number 2, we have 3,940. Remember, we want this in the form of a ones place and then followed by the remaining of that decimal. So if we would like this to just be a number in the ones place, we would need the decimal to be here. So that 3 is in the ones place and 940 is for that decimal. But because this 0 is a trailing 0, we would not need to include it. So we could just simply write this as 3.94 times 10 to the, well, let's figure out that power. Think about it. If we have 3.94, moving that decimal place here, how many times do we have to move the original decimal? 1, 2, 3 separate times. So we know this power is either going to be a +3 or it's going to be a -3. So is it a +3 or a -3? Well, let's think about this number, 3.94. 3.94 is smaller than our original value of 3,940, so we would want that exponent to be positive, so we would get 3.94 times 10 to the 3rd. And here is our solution in scientific notation. So if you envision taking 3.94 and multiplying it by 10 to the 3rd, that's multiplying it by 1,000. 10 to the 3rd is 1,000. Here's those 3 zeros for which I moved my decimal point, those 3 places. Let's move on to number 3. And number 3 pretty much already are in the form of scientific notation, but we need to multiply this by 10 to some power. Do we want to move the decimal for this? No, we don't actually want to move the decimal at all since we have the ones place followed by a decimal. So we're just going to rewrite this as 4.7 times 10 to the, well, we don't want to multiply it by anything that changes that decimal place. So if we multiply by 10 to the 0, 10 to the 0 is multiplying it by 1. And 4.7 times 1 is still 4.7. So 4.7 times 10 to the 0 is our solution for number 3. In number 4, we have 1,260,000. So where would our decimal place need to go? It would need to go right here so that we have a ones place followed by our decimal. And remember, we can drop those trailing zeros. So we want to have 1.26 times 10 to the, well, how much do we have to move the decimal place? If it started here, that was 1, 2, 3, 4, 5, 6 different times we would have to move the decimal place. And we want to increase this value, so we know that's going to be a positive 6. So 1.26 times 10 to the 6 is equal to 1,260,000. And there we have it. That's our solution in number 4. Moving on to number 5, we're working with a decimal already, but remember we want a ones place followed by whatever is left in that decimal. So in order to accomplish this, we would need to move the decimal 2 places to the right to get 6 point, well, what would come after that 6? A 0. So we don't need to include that. So we have 6 times 10 to the, how many times did we move that decimal? We moved it 2 different times. And because we moved it twice to the right, we actually increased this value, which means that in order to go back to that original value of 0.06, we would need to decrease our whole number value of 6. So we have 6 times 10 to the -2. That's our solution for number 5. And if you're confused on whether the exponents are negative or positive for the 10, again, think about when you create the number that gets multiplied by 10, if the original number was smaller, that's a negative exponent. If the original number was greater, that's going to be to a positive exponent. So let's continue on to number 6. In number 6, we have 175. So our decimal place starts here. That's our original number, but we're going to need to move it 2 times to the left in order to get our format of 1.75 times 10 to the, well, we moved it 2 times to the left. So 1.75 is smaller than that original value. So we need to multiply by 10 to the +2 in order to make those values equivalent. So 1.75 times 10 squared is our scientific notation for number 6. Let's move on to number 7. Our directions for numbers 7 through 12 are to write each number in standard notation. So essentially executing this multiplication. But remember, since we're multiplying by tens, we're just going to be moving the decimal place either to the right or to the left, depending on whether the exponent is positive or negative. So we're starting with 6.17 times 10 to the third. So we're going to be increasing this number, the number that 10 is multiplied by, since that 10 has a positive exponent. So we're going to move this decimal place 3 times to the right. So again, writing 6.17, moving it 3 times to the right. That's 1, 2, and then 3. Notice that I don't have a number on that third move, so I'm going to fill it in with a placeholder 0. Therefore, my solution now is no longer 6.17 times 10 cubed, or 10 to the third. It's 6,170. That is 6.17 times 10 to the third, written in standard notation. Think about multiplying 6.17 by 10 to the third. That's 6.17 times 1,000. So again, moving that decimal place 3 separate times. For number 8, we have 7 times 10 to the fourth. So we know that we're moving our decimal place. In order to take this whole number of 7, we're increasing it since it's a positive exponent. So this is going to be 7, moving that decimal place 4 times to the right. 1, 2, 3, 4, and filling in with zeros. So we get 70,000 as our solution in number 8. 7 times 10,000 equals 70,000. Moving on to number 9, we have 7.31 times 10 to the 6th. So we know we're moving that decimal place to the right 6 different times. So 7.31 moving that decimal place 1, 2, 3, 4, 5, 6. Our decimal will be here, and filling the rest in with the zeros. That's going to be 7,310,000. That's our solution for number 9. 7.31 times a million is going to be 7,310,000. For number 10, we have our first negative exponent for this set of directions. When we have that negative exponent, that means we're taking our decimal and moving it to the left. So we have 5.4, and we're moving it to the left 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So putting my decimal here and filling the rest in with zeros, you can see that 5.4 times 10 to the negative 8 is indeed smaller than that 5.4. And it's common to write a 0 in front of a decimal so that it's easier to see where that decimal place is. So we have 0.000000054. That's our solution in number 10. And again, scientific notation is just another way to concisely write this number. So this is a little bit easier to read than all of these zeros over here. But they are equivalent. They are the same exact number. They represent the same number. This is just a more concise way of writing it. So for example, if we had another number, let me just write out 0.00000000054. These numbers look basically the same, right? Visually they do, but this is actually, I put another 0 in here. So this actually represents 5.4 times 10 to the negative 9th. So by looking at the scientific notation, we can easily see which number is smaller. 10 to the negative 9th is going to be smaller than 10 to the negative 8th. So scientific notation is very useful, especially when working with really large numbers or really small numbers. So let's continue on to number 11. For number 11, we have 6.7 times 10 to the negative 3rd. So we're going to be moving this decimal 3 times to the left. So 1, 2, 3. Put that decimal and fill in those placeholder zeros. So this is going to be equal to 0. Those two placeholder zeros, 0, 0, 6, 7. That's my solution in number 11. In number 12, we have 9.59 times 10 squared. So we're taking 9 and 59 hundredths and multiplying it by 100. Well, all we're going to do is move this decimal 2 times to the right. So we get 959 as our solution. For numbers 13 through 16, we're going to be writing each number in scientific notation. These already look similar to scientific notation, but remember, we need a ones followed by a decimal, and then we multiply by 10 to some power. Whereas here, we don't necessarily have that ones place, or we have more than that ones place. So let's dive in, correcting these in number 13. So let's look at number 13. We would like this to be a 2 times 10 to the something, some power that we still need to figure out. So I need to actually rewrite 0.2 in scientific notation, and then once I get that number in scientific notation, I can just multiply it by this 10 to the 6th. So 0.2 in scientific notation, we know is 2 times 10 to the negative 1st, because we need to move that decimal place over 1 to the right. 2 times 10 to the negative 1st is equal to 0.2. Now, once we have 2 times 10 to the negative 1st, which is 0.2 in scientific notation, we still need to multiply this by 10 to the 6th, because that's our original number, 0.2 times 10 to the 6th. So this is going to be equal to 2 times 10 to the negative 1st times 10 to the 6th. We just need to add those exponents together since we have the same base and they're multiplied. So 10 to the negative 1 plus 6. Now, if you're confused on how I knew that I could add these exponents, I'll leave a card over here or a link in the description below, leading you to a worksheet where we went over properties of exponents and dealing with multiplication. So review that before continuing on. However, keeping up on number 13, we have 2 times 10 to the negative 1 plus 6 is going to be equal to 2 times 10 to the negative 1 plus 6 is a positive 5. So 2 times 10 to the 5th is our solution for scientific notation and number 13. Now, if this part confused you, where I rewrote the number in scientific notation first, let's start by converting this number to standard notation and then reconverting it and then converting it to scientific notation. So going a different route, we're going to take that 0.2 times 10 to the 6th and write it out. So we're going to have 0.2 times 10 to the 6th, that's moving the decimal place 1, 2, 3, 4, 5, 6 times. So we need a 0, 0, 0, 0, 0 for our placeholder. So writing this in standard form, we get the number 200,000. Now let's convert this to scientific notation. So if our decimal place is here, we need to move it 1, 2, 3, 4, 5 times to the left. So this is equal to 2.0 or 2 times 10 to the 5th. The same exact result as down below. Let's move on to number 14. In number 14, we have 30 times 10 to the negative 8th. For this one, let's start by writing it in standard notation and then go to scientific notation. So this is equal to, well, if we're moving the decimal 8 times to the left, we're taking this number 30. Here is our decimal, and we're moving it 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 0.00000030. So converting this, which is now in standard notation, into scientific notation, you can see that we would have to move the decimal 1, 2, 3, 4, 5, 6, 7 times to get 3 times 10 to the, we moved it 7 times to the right, so this 3, it needs to be multiplied by 10 to the negative 7th to be equivalent to this original value. So 3 times 10 to the negative 7th. Another way we could think about this, starting by writing 30 in scientific notation, well, that's just a matter of moving the decimal place 1 time over to the left. So 30 is equal to 3 times 10 to the 1st. 3 times 10, that's 30. 3 times 10 to the 1st. But remember, if this is equal to 30, we have 30 times 10 to the negative 8th as our problem. So we need to take this 3 times 10 to the 1st, which is 30, and multiply it by our 10 to the negative 8th. Now it's just a matter of adding those exponents. So we get 3 times 10 to the 1 plus negative 8, or 1 minus 8, which is a negative 7. So 3 times 10 to the negative 7th. That's our solution for number 14. Moving on to number 15, I'm going to start by writing 88.4 in scientific notation, since I think it's easier just to add those exponents in the end. So rewriting 88.4 in scientific notation, I would need to have an 8.84 times 10 to the, well, I had to move that decimal place to the left, so this is going to be times 10 to the 1st. 8.84 times 10 gives me my original 88.4. And that number, 88.4, is multiplied by 10 to the 3rd. So I have 8.84 times 10 to the 1st, which is 88.4, and I'm multiplying that by 10 to the 3rd. So this gets multiplied by 10 to the 1 plus 3. So 8.84 times 10 to the 4th. That's this original number in scientific notation. Moving on to our last number for this set of directions, number 16. Again, starting by rewriting 28.8 in scientific notation, well, I would need to move the decimal place once to the left. So because I'm decreasing this overall value of 28.8 and making it 2.88, I need to multiply by 10 to the positive first, because 2.88 times 10 equals 28.8. So here is 28.8, and I multiply that by 10 to the negative 9th. So this is going to be equal to 2.88 times 10 to the 1 plus negative 9, 1 minus 9, which is negative 8. 2.88 times 10 to the negative 8th is my solution in scientific notation. Finally, onto our last set of directions. For numbers 17 through 22, we're going to simplify. We're going to be writing each answer in scientific notation. And if you need more scientific notation practice, again, I'll leave a card over here linking you to another video. For now, let's move on to number 17. Now remember, these are all multiplied together. So because everything's multiplied together, I'm going to make this easier on myself. I'm going to multiply my numbers of the same bases together, and I'm going to multiply my other decimal numbers together. So 5.4 times 7 will get multiplied by 10 to the negative first times 10 to the 0. Remember, when I'm multiplying numbers of the same base, I add those exponents. So doing 5.4 times 7, that's going to give me 37.8. So I have 37.8, and I'm multiplying that by 10 to the negative first times 10 to the 0. That's 10 to the negative 1 plus 0, which is still 10 to the negative 1. So I've simplified this down, but we're not quite in scientific notation yet because I have a 37.8 when I want a 3.78. So let's rewrite 37.8 in scientific notation. Moving that decimal place over once, we'll get 3.78, and that needs to be multiplied by 10 to the first to revert back to our 37.8. So if I have 3.78 times 10 to the first, which is 37.8, and I'm multiplying that by 10 to the negative 1, combining those numbers where I have the same base, I add the exponents. So this is going to be equal to 3.78 times 10 to the 1 plus negative 1. That's 10 to the 0. So there we have it. 3.78 times 10 to the 0 is this product in scientific notation. Let's move on to number 18. In number 18, again, combining those like bases together and multiplying those decimals, 5 times 3.5 is going to give me 17.5, and that gets multiplied by 10 to the 3 plus negative 1, or 3 minus 1, which is a positive 2. This isn't quite in scientific notation yet because I need to rewrite 17.5 first. So writing 17.5 in scientific notation, that would be moving the decimal place over once. So I would get 1.75 times 10 to the first. That is my 17.5. My 1.75 times 10 to the first, but I still need to multiply by 10 squared. Now I can write this as 1.75 times 10 to the 1 plus 2, or 10 cubed. One other way to go about this would be to execute the multiplication within each of the parentheses. So 5 times 10 cubed would be 5,000, and 3.5 times 10 to the first would be 0.35. So then multiplying this number out on a calculator, I'd get 5,000 times 0.35, or 0.35, which would be 1,750. But then I would still need to convert this to scientific notation, taking the decimal, moving it 3 times. That would be 1.75 times 10 to the third. So you can go this route, converting these both to standard form, or standard notation and then reconverting back to scientific notation, or just do it out as we started. Either way, you're going to get the same exact solution, so either method is correct. One just may be easier than the other. For number 19, I'll start by combining 6 times 4 to get 24. Then I'll combine my 10 to the 6th with my 10 to the negative 1. That's 10 to the 6th plus negative 1, or 10 to the 6th minus 1, which is 10 to the 5th. So we're almost there. We just need to rewrite this 24 as 2.4 times 10 to some power. So that's going to be equal to 2.4 times 10 to the first. Multiplying 2.4 times 10, that's going to give me that 24. So if we have 2.4 times 10 to the first, that is 24. I still need to multiply by my 10 to the 5th. Now, it's just a matter of combining those exponents together with my base of 10. So since I have 10 to the first times 10 to the 5th, I'm going to add those exponents together to get 2.4 times 10 to the 6th. So there we have it, our solution in number 19. For number 20, I'm going to start by multiplying 4.11, or 4 and 11 hundredths, with 8 and 65 hundredths. So 4.11 times 8.65 is going to give me 35.5515. And that's going to be multiplied by, now combining 10 to the 5th with 10 to the negative 5th, well, 10 to the 5 minus 5 is 10 to the 0. Or 10 to the 0 is simply 1. So really, I just have 35.5515. So if I need to write this in scientific notation, I need to take that decimal and move it once to the left. So I'm going to get 3.5, and no need to write out all these decimals. Let's just go to the thousandths place. So we'll do 3.555, and we're going to multiply that by 10 to the, well, we moved the decimal place once to the left, so that's going to be 10 to the first power in order to revert it back to that original 35.55. So 3.555 times 10 to the first. That's 35.55 in scientific notation. And again, I just dropped this 1 and 5, making my number a little more concise, having no more than 3 decimal places. For number 21, let's start by multiplying our 7.68 with 9. 7.68 times 9 is going to give us 69.12. So 69 and 12 hundredths. And that's multiplied by 10 squared times 10 to the 6th. So combining those together, that's 10 to the 2 plus 6. 10 to the 2 plus 6 is 10 to the 8th. Now I need to rewrite 69 and 12 hundredths in scientific notation, and then I can consolidate those bases by adding the exponents. So 69.12, I would need to move the decimal 1 to the left to get 6.912. So it's 6.912 times 10 to the, well, since I had to move the decimal place to the left, I need to account for that fact. So this is 10 to the first. And that's also multiplied by 10 to the 8th. So my last and final step to get this in scientific notation, I'm going to rewrite 6.912, but I need to multiply together 10 to the first times 10 to the 8th, combining those by adding that exponent of 1 plus 8 to get 10 to the 9th. 6.912 times 10 to the 9th. Finally, on to the last problem on this worksheet. If you've been finding this video helpful, don't forget to click that thumbs up button. But for now, let's finish this out. I'll start again by multiplying 8.31 with 6.6. So 8.31 times 6.6 is going to give me 54.846. So 54 and 846 thousandths. Now I'm going to combine 10 to the negative third with 10 to the negative 6. So negative 3 plus a negative 6 is going to be a negative 9. So this number gets multiplied by 10 to the negative 9th. Now I'm going to rewrite 54.846 in scientific notation, and then I can combine my bases of 10 together. So I would need to move the decimal place 1 to the left to write it in scientific notation, which means that if it was in scientific notation, I would have to move the decimal 1 to the right to get back to standard notation. So that's the same as multiplying by 10 to the first. So I'm going to have 5.484, but remember, I don't want more than 3 decimal places, so as opposed to 4846, I'm going to round to 5.485. This 6 rounds this 4 up to a 5, so I have 54.85 or 5.485 times 10 to the first. And that's all multiplied by 10 to the negative 9th. Finishing this out, I'll combine my bases of 10, adding those exponents. So I'll get 5.485 times 10 to the 1 plus negative 9 is a negative 8. And that's my final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will get back to you as soon as we can. But as always, don't forget to like, subscribe, and share. Happy learning!